Scientific notation. Scientific notation is a way for writing very large or very small numbers so that they're easier to compare and to use in computations. The goal of scientific notation is to get our form to be where you have some value n times 10 raised to a power, and this n value has to have a value in front of the decimal to be 1 through 9. So if you can remember 1 through 9, that's going to be very easy. To convert to scientific notation, so we call the number, if it's not in scientific notation, we call it decimal form. So to convert to scientific notation, we are going to move the decimal point so that the number in front of the decimal is 1 through 9. So I'm going to make a little note on the side that we want the number in front of the decimal point to be 1 through 9. If we are moving to the left, when converting from decimal to scientific, our exponent will increase. This is a very, very, very important rule. So left will increase. I'm going to make a note of that over here. And if we move to the right, our exponent will decrease. Decrease doesn't necessarily mean negative. Decrease means that it's going to become a lesser value or less in value. So, looking at the first example that you guys have, we have 3, 1, 2, which is what our non-zero numbers are. And so our goal is to get our decimal point so that it's in between the 3 and the 2, but we want it, the 3 and the 1, but we want it to be that way because we want the number in front of the decimal to be 1 through 9. Okay, so because our decimal point is over here, ignore this stray mark right here. I'm not sure why that's there. Let me get rid of that so that doesn't become confusing. Okay, so actually I'm going to get rid of everything again. We're going to move our decimal point to the left until we reach that in between 3 and 1. Now because we're moving to the left, remember, our exponent increases. So I'm going to count. 1, 2, this is a little hard to draw in here, but 1, 2, 3. Give me 1 second to try to fix this. There we go. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So our number will become, if I can get my pen to work, 3, why is this giving me a hard time today? 3.12 times 10 to the 11th power. Again, notice because I moved to the left 11 places, the exponent increased from no exponent until I reached 11. Again, we want the number in front of the decimal point to be the digits 1 through 9. Now here, because our decimal point is to the left, we want to land between the 3 and the 1. So because we want to land between the 3 and the 1, we're going to have to move our decimal point to the right. Now remember that moving to the right will decrease, and since we're decreasing from nothing, because there's no exponent written, our exponent will decrease -1, -2, and so on and so forth. So I'll count for you guys again. 1, 2, 3, 4, 5, 6, 7. But because it was to the right, it's a decrease, so it's not going to be a +7. It's going to be a -7. Notice again that the value in front of the exponent is 1 through 9. So here's some more examples just to practice. This again is our exponent going to, our decimal point on the right. So because our decimal point is on the right, we're going to move to the left. And moving to the left will, of course, increase the exponent. So we're going to go 3, 6, 9, 12. Remember, we want the decimal in front of the number in front of the decimal to be 1 through 9. So we have to land in between the 4 and the 2. That way the decimal point is in between the 4 and the 2, and the number in front would be 4. So it's going to be 4.2 times 10 to the 3, 6, 9, we said 12th power. And again, why positive 12? Because we moved to the left. In this example, we want to move to the right because our decimal is all the way to the left. And we want to land on the right side of the 1 because, again, we want the number in front of the decimal to be 1 through 9. So this is 3, 6, 9, 12, 15 places. So 1, which is nice to write, 1.0 times 10, and again to the right will decrease me to the negative 15th power. I'll give you guys a second to try these, just for a quick pause, or you can pause the video. And now we're going to fix these so they become decimal to scientific. Again, when we are converting, we want to make sure that we move our decimal in such a way that the number in front of the decimal is 1 through 9. Now this negative in front will not change anything, it just means it's a negative value. Okay, so here we go. We're going to start with the first example together. Again, my decimal's here, and I want it to land in between the 3 and the 5. So I'm going to move 1, 2 to the left. So it's negative 3.562 times 10 to the 2 because I moved to the left, I increased. 3, 6, 7, 3.2 times 10 to the 7th power. 3, 6, 8, 7.89, the negative goes in front, times 10 to the negative 8th power. 3, 4, 6.37 times 10 to the negative 4. Again, decreasing from no exponent by that many places, negative 4. 2 to the right, 2 to the left, 7.4367 times 10, remember left increases. And the last example, 1, 2, 3, 6.54 times 10 to the negative 3, moving to the right, decreases. Now we are going to convert from scientific notation, which you have to kind of change your mindset a little bit. So in this case, what you're going to notice is to convert a number from scientific to ordinary, or what we call decimal, the power on 10 indicates how many places we will move. So if the power on the 10 is positive, we will move to the right. If it is negative, we will move to the left. Remember, we're now going from scientific to decimal. So I'll do these 3 examples. So here, this is going to swing me 2 to the right, 4, 0, 1. This is going to swing me 6 to the right, 1, 2, 3, 4, 5, 6. And this is going to swing me 3 to the left. So when it's to the left, I would give myself a little space, 1, 2, 3. And remember, these empty loops get zeros. I'll pause to allow you guys to try the next 2, or you can pause the video and try and then resume. So in this example, the 9 is going to swing me out, 9 to the right. 1. So I just like to count 1, 2, 3, 4, 5, 6, 7, 8, 9. This will be 7 to the right, 1. So that's 1, 2, 3, 4, 5, 6, 7. 5 to the left, so give yourself a little bit of space. So we go 1, 2, 3, 4, 5. So remember, those empty loops are zeros. So we have 1, 2, 3, 4 empty loops, 789. 7 to the left again. So give yourself a little space in front. 1, 2, 3, 4, 5, 6, 7. So it's going to be point 1, 2, 3, 4, 5, 6, 3, 45. And then this is going to be 8 to the left. That would just be 1, 2, 3, 4, 5, 6, 7, 8. So that's going to be 7 zeros. and a 54. And this is 6 to the right. 1, 2, 3, 4, 5, 6. So be careful when you're going from one direction to the other. When we want to add and subtract with scientific notation, the easiest way to do this, unless you have a fancier calculator, is to expand them from scientific to decimal form, combine, and then rewrite. So this would be 3 with 6 zeros moved out. This is 5 with 2 zeros moved out because your exponents are positive. Adding them together, and then here's the scientific form. 1, let me get my pen. Okay, so 1, 2, 3, 4, 5, 6. And we rewrite all of those important digits. So this one actually has a little error in it. It should be 3.0005 times 10 to the 1, 2, 3, 4, 5. It's still 6, just I missed a 0. This is going to be moving the decimal out 9 places to the right. This is moving out 8 places to the right when combining, and then we have 3, 6, 9. So I'll pause for a minute, let you guys try, and then I'll work these through. So this would be 7 moving out to the right 4 places. So that's going to be 7, 1, 2, 3, 4. This is 3 places. 1, 2, 3. 7, 5, 0, 0, 0. And then I'm going to swing in 3, 4 places to change into scientific form. Remember, because I'm moving to the left, my exponent increases. The next one, so this is going to move me out 8 to the right. So 5, 1, 2, 3, 4, 5, 6, 7, 8. This is going to be 6 to the right. So 1, 2, 3, 4, 5, 6. When you combine those, you get 5, 3, 7. And you can use your calculator for that. Let's count the zeros. 1, 2, 3, 4, 5, 6. And then we're going to swing in 3, 6, 7. Oops, 8. So 5.37 times 10 to the 8th. This is actually a review topic, but it is important to know how to really convert, so nice to go over. Multiplying and dividing should be a little bit easier. So with multiplying and dividing, you're just going to multiply the values that are in front. And then remember the rule for exponents. I went over this in our first lesson. When we multiply bases that are the same, we add the exponent. So to work out this example, 6 times 4. 6 times 4 gave us 24. And then 2 plus 5 in the exponent gave us 7. Now, interestingly, in this example, and there's questions like this in your homework, this is not good for scientific notation because we want the decimal to land between the 2 and the 4. So we have to swing one to the left. And remember the rule when we swing to the left. Swinging to the left will increase my exponent, and it increases it by however many I move. So because I was at 7 and I move 1 to the left, an increase by 1 would be 8. If I had to go the other way, just a hypothetical, and I'm actually going to do it in a moment, but if I had to go the other way, so if it was 0.24, let me start that over, 0.24 times 10 to the 7th, and I had to go to the right, moving to the right decreases, and I get 2.4 times 10 to the 6th. So that's the important thing. If we're not in appropriate scientific form, moving to the left will increase my exponent, moving to the right decreases. And if you remember that, you'll be in perfect shape. So just keep that rule in mind. If your answer is non-scientific, you must adjust. If you have to move, so this the should have been over here, decimal point to the left, the exponent increases. And if you move to the right, Another typo, sorry guys. It decreases. So here, 0.6 times 0.3 is 0.18, and when our exponents are added, we get a 2. So here it is. I need to move to the right, which decreases my exponent, so a decrease by 1 from 2 would be 1. Here we're going to divide instead. So 1.2 divided by 4.8 is going to be 0.25, and you can use your calculator for that. 4 minus 8 for our exponents gives me -4. Again, I need to move to the right. Moving to the right decreases me. A decrease from -4 would be -5. 8.4 divided by 4.2 would be 20. Again, use your calculator. We know 20 is going to be a problem, so we're going to fix it. -2 minus 8, remember when we divide bases that are the same, we subtract, is -10. And again, because my decimal's here, I'm going to move to the left. Moving to the left by 1 increases. An increase from -10 would be -9. So here are some examples to try. You can pause the video to try. Otherwise, let's keep working. So when we add and subtract, remember we're going to expand. So this is 23,000, 100 plus 6, and then we're going to swing 3 to the right. So 1, 2, 3. And we end up with a sum of 9,200. We're going to move 3 to the left to rewrite in scientific form, and moving to the left increases. An increase from nothing would be 3. Same thing with the next one. So 4.4, we swing 6 to the right. So to the left, 2, 3, 4, 5, 6. And then in this one, same deal. So 8.8, we're going to swing 6 to the left. So 1, 2, 3, 4, 5, 6. When we add these together, we get 0, 0, 0, 0, 1, 3, 2. And to convert from scientific, remember we want to land over here. So 1, 2, 3, 4, 5. Remember, because it's to the right, it's decreasing. 1.32. For the subtraction, same deal. So we're going to swing our exponent 4 to the right. So 1, 2, 3, 4. Minus, we're going to swing 2 to the right. Combining these, we get 60757. And then we're going to move in 1, 2, 3, 4. 6.0757 times 10 to the 4th power. Left increases. Last one. 832. So again, we're going to move in 1, 2, 3 to the left. Minus, and then we're going to move 4 to the left. So 1, 2, 3, 4. Combining these, we get 0.00773. And again, we're going to go 1, 2, 3. 3 to the left is a decrease, 7.73. And again, I want to reiterate that moving to the left increases, moving to the right decreases, and that's going from decimal to scientific form. The only reason that we change these is for addition and subtraction. For the multiplication and division, we apply the other rules. And again, one other thing to really reiterate, make sure that you understand that every time we are in appropriate scientific form, our value in front of the decimal is 1 through 9. Here, 2.4 times 1.5. So again, you can use your calculator for that. So 2.4 times 1.5 is going to be 3.6. And then we add our exponents. Because our decimal value in front is 1 through 9, this is appropriate scientific form. 5.2 times 1.1 is 5.72. Adding our exponents, negative 9. Again, because the value in front of the decimal is 1 through 9, we're good. Now, 8.08 divided by 4 is 2.02. Remember that when we subtract our exponents, you have to be careful. So it's negative 10 minus negative 3, which is positive in between, so negative 7. And again, because our value in front of the decimal is 1 through 9, we're in good shape. 5.25 divided by 3.5 is 1.5. Subtracting our exponents, 8 minus 3 would be 5. And because the value in front of the exponent is 1 through 9, no need to fix any decimals. This one is a little more of a challenge, but it's not too difficult. So all you want to do is simplify the top first and then divide after. So using your calculator, again, my pen is gone, so let me grab that. We want to have 3.2 times 4.6. So let me kind of draw that out. Well, you guys are getting the idea. So 3.2 times 4.6 was 14.72. See if I can do that now. I guess because it's too high. Adding the exponents on top, we get 11. And I like to rewrite what I have so I know what to do next. So 4.72 divided by 2 is 7.36. Again, just use your calculator. And then 11 minus 3 is positive 8. 2.1 times 1.8 is 3.78 times 10 to the 5th. Remember, we're adding those exponents on top. 3.78 divided by 3 is 1.26. Subtracting the exponents, again, I'll do it on the side. 5 minus negative 3 is 5 plus 3, which is 8. And again here, 1 through 9. Here, 1 through 9. These are just quick comparisons, so I don't want you guys to worry too much about these, but basically here, you would say that 10 to the 24 divided by 10 to the 18th is 10 to the 6th, so that's the difference between them when we compare. 10 to the 27 divided by 10 to the 17 is 10 to the 10. So basically here, 10 to the 24th is 10 to the 6th larger than 10 to the 18th. Here, 10 to the 27th is 10 to the 10 times larger than 10 to the 17th. And 1 trillion is 1 times 10 to the 12th. 1 billion is 1 times 10 to the 9th. And this would be 1 times 10 to the 3rd. So 1 trillion is 1 times 10 to the 3rd larger than 1 billion. Again, just a little food for thought. Our last question asks you to compare the population of the world to the US population, so comparing the two, and then comparing the energy consumption. Now, you weren't told right around here, so I'll just kind of walk you guys through. So the US population compared to the world population, the US population can be written as 3 times 10 to the 9th power. 3 times 10 to the 8th power, because 300 million looks like this. So we would go 3, 6, 7, 8, so 3 times 10 to the 8th. And the world population is 7 billion, so that's 1, 2, 3, 4, 5, 6, 7. Let me make sure I got, so that's 1,000, a million, a billion. So that's 7 times 10 to the 3, 6, 9th power. When you put this in your calculator, you can do 3 over 7, or a decimal, times 10 to the negative 1st, and you would get 0.0429. So from our last lesson dealing with percents, this is 4.3%. Remember, we moved to the right. So we would say the US population is 4.3% of the world population. Now, energy consumption, the US consumption versus the world consumption. The US consumption is 1.0 times 10 to the 20th. The world consumption is 5.7 times 10 to the 20th. So these actually cancel because dividing anything by itself gives us just 1. So putting that in your calculator, you get 175 after the decimal. Moving that to the right, we get 17.5%. So even though, I'm trying to write the word consumption, but even though our world population, the US is only 4.3% of the world population, the US uses this much of the world's energy. So that's how you can compare using scientific notation. I hope the video helps. Try the homework, and if you have any questions, let me know. I'm just going to work the last slide out quickly so you guys can compare, but everything has been covered that involves scientific. Convert from scientific to ordinary. So we're going to move our exponent, our decimal out by the exponent. So here the exponent is positive 4, so we move 4 to the right. 1, 2, sorry guys, 3, 4, 5 to the right, 5 to the right again. So 1, 2, 3, 4, 5. 3 to the left. So 1, remember this is 1, 2, 3. 2 to the left. So 1, 2. And 6 to the left. So 1, 2, 3, 4, 5, 6. So it's going to be 5 zeros with a 3. So again, going from scientific to decimal, positive exponent is to the right, negative exponent is to the left. Now we're going from scientific to decimal. So left increases, right decreases. Decimal to scientific. 1, 2. I move to the left, so I increase. 1, 2, 3, 4, 5. Left increases. Right decreases. Left increases. Left increases. Right decreases. Every time I am in scientific, the number in front of my decimal is 1 through 9. Last 4 examples. So with multiplication, I multiply the numbers in front. I add the exponents. 1 through 9. Multiply the numbers in front. Add the exponents. Addition, I change to decimal form. And then I correct it to be scientific. Moving to the left, increases. Finally, with division, I divide my numbers in front. I subtract my exponents. My value in front is 1 through 9. Good luck with the homework. Please email me if you have any questions. Have a great day, guys.